Good morning, everyone. I hope you are doing all right. So on the screen, I wrote 3 definition or vocabulary terms we learned last class. Okay. And so position has value and direction. That's why it's called vector. And we measure value from some reference point, also known as origin. And we represent position by drawing a line with an arrow. It has value, it has direction. And we denote position, for example, initial position, something like X for the position, and I means subscript for initial. And we can write that as, let's say, negative 1 meter or positive 1 meter, negative or positive 1 meter. So these signs means direction. So those are the main thing we learned. And displacement. So we represent displacement, or we denote displacement by writing this. So delta here means change and X means position. So displacement is change in position, and its formula or its definition is final position minus initial position. Okay. And velocity, how the displacement is changing over time. And that is, we call average velocity. So this AV means average. Here, the subscript means average. And it is displacement over the time interval. And there are distance, there are speed, and so on, what the differences and so on. We talked about those in last class. So today, we will learn to visualize these things: position, displacement, velocity, by making diagrams and graph. One such diagram is called motion diagram. And another method of visualization is graph. Okay, so what is motion diagram? It's a simple idea. Okay. And by the way, I don't see any of you. So if your situation or surrounding allows, please turn on your video and so that you don't get distracted and it feels like a classroom as well. Okay. So we want to describe motion. What is motion? When object goes from one position to another position, another position, another position. So position changes with time. Okay. So let's suppose you are looking at a bug, some sort of bug crawling. Okay. And what happens? This bug may be moving sometimes, may not be moving. Okay. But let's say it is moving. So it starts moving, you want to keep track, you know how fast it is moving and so on. So you decide to visualize motion by, let's say, you have, let's say, some sort of crane or something like that. You see a bug crawling on the paper. So what you do is you decide to mark its position every second. So when you first look at it, the bug was here. So my bug is this. Okay, I'm not very good at art. So I can draw circle, sphere, and dot for almost everything. Okay. I can draw whole earth as a dot, whole cow as a dot, and so on. And that's how it is usually done in physics. Okay. So this object here, and you decided, okay, right now I started, tracking its position. So you put a dot with a crayon, and then you waited for another second. So let's say you started here. Let's say this is 0th second, first observation. Okay. And then what happens? It moves there. In next second, you see over there, and you put another dot. Okay. So this is in 1 second, right? And keep doing that. And this is in 2 seconds. Oh, 3 seconds. It arrives over here. So now bog is gone. Bog is not there, let's say. What you have is just these dots. So now you are left with the dots. So now you want to analyze what kind of motion, how the position was changing, what was the displacement of the object or the bug, okay? And what was velocity? Was it moving faster and faster, or was it moving with the same speed all the time, or was it slowing down? Okay, so those kind of things you wanna find out looking at these dots. So time information is there. So position information is given in terms of dot, right? So now let's say you are interested between these two dots. So you can say this is initial position and this is your final position. So final doesn't have to be all the way to the end. So let's say you are interested between 2 points. So one is initial, one before is initial, and then one after is final. So that's how we look at it. Okay. So now you have initial and final position. Do you know how to draw displacement by looking at, from how to draw displacement if you know initial and final position? Do you know that? What's the displacement in this case? Displacement is final minus initial. To visualize that, what do we do? If you forgot from last class, don't forget anymore. I'm going to tell you. You draw starting from initial to the final position. You draw an arrow. You draw a line with arrow starting from the initial to final. Okay. So that's your displacement here. Now, how about displacement in second, in between first second and second, second? If you want to find that, what do? You do the same thing. And this is displacement. So now, since there are, displacement here, and their value may not be same, so we may want to differentiate them by writing delta x1, delta x2, means displacement for first second, displacement for second, something like that. Okay, we just differentiating that. And if we keep doing that. So now you have displacement from the dots, the position you had. Okay, so these dots are called motion diagrams. And from motion diagram, you can tell about the position and how position is changing, means displacement. So what do you think? Is displacement same during first second, second, and third second interval? See, we are looking at the same time interval, 0 and 1, first, 1 second difference, right? First and second, 1 second difference. 2 second and 3 second means 1 second difference. So we are keeping time interval same. So in motion diagram, that is important. So even if you are not told about time, what you know is time interval, they are same between the dots. Okay. So what do you see about displacement? Is the direction of the displacement changing? Yes or no? Can you type that on the chat window? Is the displacement, direction of displacement changing? Yes or no? Okay, keep coming. So you can do everyone message today, okay? So which way bog is moving here? Thank you for your response. Which way is the bog moving? It was here, it went there, it went there, went there, right? So let's say it's going to the right on the screen. When it went from here to here, it went to the right. From here to here, it went to the right or left or some other way. So I see right on the screen. So it was right, it was moving to the right, again moving to the right, again moving to the right. So did the displacement, I mean, direction of displacement change? Looks like it did not, right? Direction did not change. What changed is value. So arrow is pointing in the same direction, so means direction is same. But the value, what do you look at? You look at the relative lengths of the line for the value. Are the lines getting longer and longer? Yes or no? So they are getting longer and longer means displacement, value of displacement is changing. Direction not changing, but value is changing. So displacement is increasing. So displacement is getting bigger and bigger. And now think about velocity now. Velocity is displacement divided by time. And by the way, when object is just keeps moving in same direction, the value of displacement and distance, they are same. They are same, okay? Distance and displacement, they're going to be different. Value going to be different if the object turns around, changes direction, okay? If it just keeps moving in the same direction, then what happens? Distance and displacement are same. So in this case, if displacement is too much for you, you can also think in terms of distance in this case because it's moving in the same direction. So distance is increasing. It's traveling more and more distance. Value of displacement is getting bigger and bigger. Look at this formula here, formula of average velocity. Displacement divided by time, right? So displacement increasing means average velocity. What's happening to the average velocity? Is it increasing, decreasing, or remaining same in this case? Average velocity, is it increasing, decreasing, or remaining same? Can you type one of the choice? Okay, displacement increasing means velocity is also increasing. Great. So now, what that means then, you can look at, once you have dots, you can draw a line connecting dots like this. See, you connect two dots, okay? You don't just draw one single line like this. Rather, you draw several line segments, arrows between the dots, okay? One arrow between two dots like this. And now you can just look at the arrows. Let's suppose dots are not there and you are given something like this. What can you tell about the motion? You say displacement is increasing and it is moving to the right and its velocity is also increasing. Got it? Velocity is also increasing. Velocity is also changing. When velocity changes, we call that acceleration. So how do you write average acceleration? Change in velocity over time. See, you can tell about the acceleration as well, whether object is accelerating or not, just by looking at motion diagram. So you are given dots. Now you can tell about the displacement, whether it's increasing or not, what direction object is moving, and then how is the average velocity changing or not, okay? And that means whether object is accelerating or not. If velocity is changing, object is accelerating. Even when these arrows get shorter and shorter. So we may have something like that. At the beginning, it may be moving faster. And then now slowing down. Okay, moving faster. Slowing down. Both cases, object is accelerating. Why? Because velocity is changing. Velocity changing means it's accelerating. So from motion diagram, what are the things you can tell? Displacement. Of course, motion diagram is drawn by using position. So you have position, you have displacement, and you can figure out what's happening to the velocity. And let's say you draw that in paper and you measure this distance. So that means you have the displacement. And since you already have time, you divide that displacement by time, you have velocity. Actual values of velocity you can calculate from there. What was the velocity between these 2 points? What was the velocity between these 2 points? What is the velocity between these 2 points? Okay. And once you have velocity here, and they are changing, so you can find change in velocity from there and divide that by time interval. And you have acceleration, average acceleration between this point and that point. And you can do the same thing between this and that interval and so on. So those are the information you can figure out just by looking at the motion diagram. Okay. So motion diagrams they have dots and arrows. Sometimes it may be just dots. So you have to fill in by drawing the arrows. Okay. So what do you think? Are you good? How to read position, displacement, velocity, and acceleration from a motion diagram. Can you do that? Think about it, okay? And all these things are also in my note. If you need to review, you can go back and review. And starting from this, I will be also posting the recording. If needed, you can go back and watch the recording. But this is going to be long and boring. Okay, it's not going to be fun. So do not count on that. Just pay full attention and learn right from here. But just in case, if you miss something, then you can go and watch, okay, if you have to review something. So that's not an excuse for going on phone and distracting yourself from the class because the video going to be there, okay? You will be even more distracted while watching video, okay? So those are the things I am showing you here in the slide, okay? The things that I talked about. So now here is a question. So in this case, object starts from here. Initial position is here. And then it starts moving something like that. It says moving to the left. From that, you should have this information. And looks like I forgot to start clicker. So this is clicker question. So let me find out the clicker app. And you also want to turn on your clicker app. Okay. So I'm giving you a minute and 30 seconds in this case. Thirty more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Oh, forgot to stop. Okay, let's see. So mostly we are getting B. Let's see if that's correct. So it starts from here, so goes there. So if I were to draw a displacement, so this arrow is proportional to displacement and also proportional to velocity because time interval for all of them are same. So you see length of the arrow is getting smaller and smaller means it's slowing down. Yes. Okay, so B is correct answer. So now that is motion diagram. Now graph. I already posted first physics worksheet. So worksheet 0 is algebra. And by the way, I have extended the due date for the algebra just in case if you did not do it for some reason and did not submit, or you did it not the way I asked you to do it and you want to revise and submit, you can still do it. And I think I extended until Friday or Saturday. I want everyone to do the algebra and learn it the way I have, showed you, because that's how we're going to be doing algebra. Otherwise, you'll find this class unnecessarily hard because of the algebra. Okay. Okay. So first worksheet I have already posted. So first worksheet is about graph and motion and graph. Okay. Okay, thank you, Lily, for replying for the slide. And I noticed some of you still did not, log in using the SSO option. So very first slide from on the last class have that information how to log in. So next time when you log in for this class, please use the SSO option rather than just logging in using the random Zoom thingy, okay? So graph. So graph also has position and time information, the motion graphs, okay? Graph can be of several types, several things, right? Motion diagram has position and time information. So first graph we study is position time graph. So position, we denote that by X, and time, we denote that by lowercase t, not uppercase, okay, lowercase t, and unit of time is second, and unit of position, they are meters, okay? So we already looked at motion diagram, something like this. Now let's suppose, so first of all, in this case, what's happening is the object, is object speeding up? So now let's see, motion diagram. Look at the motion diagram. Now, is object speeding up? Oh, how do I make the question? The object, choice A. So I'm going to be opening the clicker for a brief moment, okay? Speeding. B, slowing. C, constant velocity. Means neither speeding nor slowing down, okay? So three choices. You have 30 seconds. Go ahead and poll on this. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay. So let's see what we got. So mostly A, almost all of them are A. So it's speeding up. So that is correct. So if I were to draw a line, I see the line is getting longer and longer and longer. And why am I drawing upward lines, not downward line? It's because, see, 0 second here means that's the starting point. So 0 second, 1 second means it must be moving that way, not the other way around, okay? And it also shows you, hey, it's moving to the right, something like that. And let's say this right is positive, okay? So now let's make graph out of that. So this graph has a position information and time information, okay? Position and time information. At 0 second, so 0 second in the graph would be here, this point, right? Here, position informations are just given by the dots themselves, rather than giving you 1 meter, 2 meters, something like that. You are given just the dots. So think of that's the position, means the position gonna be here. In 0 second, position is here. In 1 second, position is here because 1 second time is there, and position is right here. So this is position, this is time, 1 second. So that means on the graph, that point gonna be dot over there. So that's how we make graph, right? Out of pair of numbers. Value on the time axis, those are the times, 1, 0, 1, 2, 3, 4. How do I know those are 2, 3, 4? because motion diagram, they have equal time interval. If I know the time interval between these 2 points are 1 seconds, the time interval between these two are also 1 second. These two are also 1 seconds, okay? Okay, so now once we have dots, okay, so I went all the way here in the 4th second, and you see that's that. So once you have dot, you can draw a nice curve or line. We call that trend line. So a graph have just a line. There may not be dots. Here, when we are doing experiment and we are making graph from the data, then in that case, you may have dots like this, okay? But usually this is how the graph looks like. There are no dots, just a line or curve, okay? That's how it looks like. So basically this trend line is like a drawing the through the average of the dot, so it doesn't have to pass through the each and every dot. Sometimes dot may be slightly off from the line, okay? That may be case. But once we have trend line, we forget about dots. We forget about the dots. So let's suppose another motion, the graph looks something like this. So you can make graph from the motion diagram, but once you have graph, you can tell about the position, displacement, average velocity, and acceleration from the position versus time graph. Okay. Remember, what did we learn from the what can we learn from the motion diagram? Position, displacement, velocity, acceleration. Similarly, from a graph, position versus time graph, you can tell about position, velocity, displacement, and acceleration. Okay? So these are example of some graph. And graph may not always start from the 0. For example, in this case, it's starting from the 2. So at the 0 second, position is 2. So that means x at 0 second is 2 meters. Okay. And over here, there was this direction written as a right here. And here I'm just writing positive. So instead of writing positive, right, I'm writing positive. So positive and negative can be assigned for right, left, east, west, any direction. Any direction can be assigned as a positive. Once you assign that, its opposite direction is negative. So that's how this sign convention works. So positive and negative sign in front of vector means a direction. Okay. So now, here is another question for you. Oh, it's overlapping here. This is displacement. So you have a minute to respond to this question. Thirty more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. So let's see what we got here. So mostly E. So that is correct answer. You cannot directly read displacement from graph. You need to read initial position. See, displacement means this. So you need to read this, you need to read this, and then calculate displacement. So that's how you find displacement from position versus time graph. So what is position at, let's say, 2 seconds? How do I find it? I go to the 2 seconds time and then draw a line. So that's dot over there. And then I read that number. So it looks like that could be somewhere between 3 and 4. Okay. 3 and 4. So if you have to, you can just approximate, let's say 3.5, something like that. And so that's the position at 2 seconds. And if I say that is initial position, then that is like 3.5 meters. And these numbers, they are positive. So that means it's positive 3.5 meters. Okay. Okay. So now moving on, I have another question for you. So let's actually go ahead and find the displacement. So ignore this one. Oh, ignore this for now. Okay, this one. So you have, oh, what happened? This is supposed to be meters. My bad. These are meters, okay? I added one more option here. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see what we got. So we got all of them. There are mostly B and A. So displacement means what? So whenever you are asked to calculate displacement, which is change in position, which is final position minus initial position. So initial position, it says first 6 seconds. So that means we are going from 0 seconds to 6 seconds. There. In 0 second, what is the position reading? 2 meters. So xi is positive 2 meters. And how about xf? In 6 second, reading is 14. So positive 14 meter. So what's the displacement then? Displacement is positive 14 minus positive 2 meters means it is 14 minus 2 is 12. So yes, B is correct answer in this case. So displacement here is positive 12 meters. Okay. Are we good? Any question? Anything you like to add? Okay, I don't hear anything and I don't see anything on the Zoom, so I think we are good. So now, that's the displacement. Can we find average velocity from here? So once you have displacement, you can find average velocity by just writing displacement over time interval, means positive 12 meters. Divide that by 6 minus 0 is 6 seconds. So this is positive 2 meter per second. So that's the average velocity from the graph. Another way, connect these 2 points using a line segment like this, straight line segment. Find slope of the line segment. So what is slope? How do we define slope? How do we calculate slope? Anyone? Suggestion, please? Turn on your microphone or type that on the chat. How do I calculate slope of this line here? Okay. Okay, I see rise over run. Okay, that's great. Okay. So what is rise in this case? So this line starts from here, goes all the way here. So rise is change in position in vertical direction. So that's what the rise is. And turns out that is same as displacement. You see that? Right? It started from here, it went there. And see how the object is just moving in a straight line. But graph is something like this here. Graph is not straight line like this. So remember, or like this. Remember, graph is not a path. It is not a highway. It is not a road object traveling to. It is the information about position and time. It's the visualization of position and time. So keep that in mind, okay? Don't think object is crawling over here. No, it's not doing that. The graph does not mean that, okay? It is not path of the object. Okay, so that's a rise. And what is run? So run is change in horizontal direction. So we can calculate run something like this. And this run is time interval. So rise over run. And for position versus time graph, rise happens to be displacement. And run happens to be time interval. And from physics, we learn this is the average velocity. So you can draw a line segment connecting 2 points of interest and find the slope of that line. That's going to give you average velocity. So that's how you can find average velocity from graph. Compute displacement, divide that by time interval, or equivalently, find the rise and run, means find the slope. Slope of position versus time graph is slope of the line segment connecting 2 points of interest is the average velocity between 2 points on the graph, okay? So now I answered the average velocity here. So we talked about average velocity. So average velocity is for time interval. For example, from 0 seconds to 6 seconds, or from 1 second to 2 seconds, something like that. But when we are driving, our speedometer shows you a particular value of speed at that moment. That is the instantaneous speed. If you include the direction at which you are driving, that is instantaneous velocity. So now from graph, how do you find instantaneous velocity? So for that, what do we do is we draw a tangent line. See, I have written that down. So since it is instantaneous, you will be given just one time, not two times. For average, you will be given two times. For example, first 6 seconds. It did not say at 6 seconds, rather it said first 6 seconds. That means it's starting from 0 to 6 seconds. Okay. For the average, you'll have information about time interval. But for instant, it's going to be just the moment, a particular time. Just like it says, what is the instantaneous velocity at 5 seconds? So a time is given. It did not say first 5 seconds. If you say first 5 seconds, that would be average velocity, not the instantaneous velocity. So, for example, let's say, what is instantaneous velocity at 5 seconds? Okay. So how do we find instantaneous velocity at 5 seconds? First, we have to look at the position on the graph, the point 5 seconds over there. Okay. So 5 seconds is here. That means that point on the graph is that. So that's where we want. And now we want to draw a tangent line at that point. Oh, what is tangent line? So let's take a look. This is the easiest way to draw a tangent line. Easiest way to draw a tangent line. So you already know a point where you need to draw a tangent line, right? Because it said, hey, what is average velocity at 5 seconds means you already know a point. A point is already given. But you can draw several lines passing through a point. Which one is tangent? How do you draw a tangent? So that's what I am showing you. Pay attention. 100%. Are you there? Okay, I hope so. So now, put another point right next to that towards the increasing time on this side. Another point. And all these are in my note as well. Another point. On that side, at increasing time. See, not on this side, no, not on that side. That would be decreasing time side. See, that would be less than 5 seconds, right? That would be less than 5 seconds. We want more than 5 seconds. Now we have two dots, and these dots should be as close as possible. Keep that in mind, okay? Once you have that, now you can draw only one line passing through 2 points. You cannot draw any other line if you drew it correctly, okay? You can now only draw one line, and that line is called tangent line. So how does it look like if you draw it correctly? Kinda, let's see. If you use scale, it's gonna be easier, I think. Close. So if we draw it correctly, this line not gonna cross the original curve. If it's crossing original curve, that's not a tangent line. Okay. So what happens is it just passes through just touching that, okay, that point of interest. Okay, it just passes through by touching the point of interest. Think about this is curve, right? If I am drawing a tangent line there, then what's gonna happen is this line gonna just cross that. It's not gonna, I mean, this gonna just pass by just touching that. It's not gonna intersect. It's not gonna intersect. Okay. And now just find the slope of that line. So did you learn how to find tangent line? How to draw a tangent line? Hey, so can you draw one near the 2 seconds, at the 2 seconds? I am hoping you have this slide open somewhere or printed, something like that. Okay, so that you are following and doing the things I'm asking you to do so that you will keep learning, don't fall behind. Okay, so did you draw it? So even if you don't have this printed slide or you haven't opened this, just draw a curve like this and put a point and draw a tangent line there in a paper, piece of paper. Okay. So I am drawing it now. Okay. So this is tangent line at 2 seconds. And this is tangent line at 5 seconds. Slope of these lines at those points gives you instantaneous velocities at those points. Now, tangent at 5 seconds, tangent at 2 seconds. Now here is a question for you. You don't have to calculate. You should be able to tell just by looking at how the line is sloping, right? Think about you are on a trail, like some sort of hiking trail. Which one is more steeper, okay? Okay. So you have 30 seconds to answer this. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay. Let's see what we got here. So mostly B. So see, slope, just like a trail, slope of a trail or road, we say, okay, more steep means more, slope, higher slope, right? So basically, if it is a flat road, often we see flat road, zero slope. And then if it is going downhill, negative slope. If it is going uphill, positive slope. Okay, so that's how it works. And how do you find slope of these lines? Just mark any 2 points on that tangent line, convenient point, and find the rise over run. Rise, run. Any 2 convenient point. I did not choose, looks like I did not choose the most convenient point here. You can draw these lines as long as you need to find some convenient point to read. Okay, what are convenient point to read? If it's crossing something like this, then see, there is 7 there, there is 16, so that is the convenient point to read. That's what I mean. Okay, so now here is another question for you. You have 1 minute and 30 seconds to answer this question. Thirty seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Let's see what we got. Okay, we got all of these. So we are talking about average velocity. Right? So what did we learn about average velocity? This was instantaneous, where you draw the tangent lines. Average was this one. Connect those 2 points, you drawing a line segment and divide that by time interval. See how quickly you guys forgot? That's not good, is it? So average velocity you find by using A. Oh, that was the displacement. My bad. I forgot. Okay. find the displacement between 2 points on the graph line and divide the displacement by the time interval. Okay, that's one way. Draw tangents at those 2 points and find their slopes to compute the average velocity. It looks like B is the best choice in this case. Okay. So that was the displacement, right? So not the average velocity. So this is displacement. This is average velocity. Draw tangents at those 2 points and find their slopes to compute the average velocity. Actually, you can use those slopes to find average acceleration, not the average velocity. Okay. So and looks like if we are talking about whole process, we can have E as the correct answer as well, looks like. So both A and B may, can be combined to find it. So I think if you are given just one choice, B would be best choice in this case. But you can include A on that one if you're talking about process, right? So you draw a line and then find the displacement using that. So again, best choice would be B, but we can say, okay, in the process, A may be included, A can be included, right? So both this and that can be used as a process, okay? But C is definitely not. So here, what we saw is going back. Here, we saw slope is increasing, isn't it? That means velocity is changing. So velocity is changing. Means object is accelerating. And if you find slope of this and that and find the use that average velocity to find the uh, use those instantaneous velocity, you can do that and find average acceleration if you like. So velocity final minus velocity initial means change in velocity, divide that by time interval, okay? That is delta V, and that gives you average acceleration. So you can find those things from a graph, okay? Oh, we passed 9 o'clock. So let's take a break. So I'll see you in 9:09 or 9:10, okay? So here is another question about position versus time graph. So I'm opening the poll and you have a minute to answer this question. Thirty more seconds. and 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay. Let's see what we got here. We got B and C only moving during 3 to 7 seconds, accelerating between 3 to 7 seconds. Okay. So let's see. Accelerating between 3 and 7 seconds. So position versus time graph. If something is accelerating, what has to happen? Velocity has to be changing. And when something was accelerating, graph looked like this curved line. Over here is a straight line. Straight line has a one slope. One slope means one velocity. That means velocity is not changing. Velocity is constant. So that's why it is not accelerating between 3 and 7 seconds, okay? It is moving only during 3 and 7 seconds, and it has a constant velocity. Why? Slope is constant, fixed. See, slope is not changing, okay? Over here, what's happening? Are they moving? It's not moving, right? So velocity is 0. Why? Slope is 0. It's a flat line. 0 slope. And by the way, we started from last class, leftover slides from the last class, and we are moving towards the new class today, okay? So you may have to open 2 files for to complete today's class. And same thing here, same thing, okay? So correct answer in this case is B, not C. Accelerating means velocity changing, means slope is changing. One line, one straight line has only one slope. 0 slope, slope is increasing, maximum slope. Vertical line has the maximum slope, okay? And slope can be positive or negative. In a graph, this line has a positive slope because rise is positive. But if we had a line like this, it's a negative slope. Rise is actually fall. It's falling rather than rising. So negative slope. So negative rise. Fall is negative rise, for example. Okay. So that's how this position versus time graph looks like. That's how they work. And here is one more question related to the graph and motion diagram. Oh, the graph here between 2 seconds and 8 seconds. Displacement. You have a minute and 30 seconds to answer this question. You may have to write formula and do some calculation on top of reading the graph. 30 more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Let's see what we got. Mostly C. So how do I find displacement? So whenever I read displacement word, I write this. So that means I need this and that. So that means this is gonna be my xi positive. So it's between 0 and 4. So I can say this is 0.2 meters and 8 seconds here. So if I read that, that looks like positive 1.8 meters, right? So that's my xf. So positive 1.8 meters minus positive 0.2 means positive times negative is negative. So I can write that. So positive 1.6 meters. So if I were to draw a line connecting something like that, looks like that's going to be the displacement. Okay. And if you want to find the average speed between these 2 points, then you can find the slope of that one. But here the question is only about displacement. So yes, C is correct answer, just like most of you identified. Great. So now here is position versus time graph, and you need to tell. So now you know what kind of motion it is based on position versus time graph. So which motion corresponds to which motion diagram shows that one there, right? Or none of these. So you have a minute to answer this question. Thirty more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see what we got here. So mostly A, and that is correct answer. Constant slope means constant velocity. So which one here represents constant velocity? The gap, the line, if the line is not changing direction and the value, that means that shows you the constant velocity over here. So that is constant velocity. Not changing means constant. Over here, increasing or speeding up. Over here, looks like slowing down. Okay, so that's why A is correct answer in this case. Okay, so now here is another question. So think in terms of slope. If you are looking for the speed or velocity, you need to think in terms of slope. Okay, slope of the line segments. You have a minute and 30 seconds to answer this question. Oh, my bad. Let's say positive means forward, okay? Oh, 30 more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, so I received a comment here. The question is not showing on my clicker.
Thank you.
So unfortunately, I cannot, do anything about that, but hopefully you can see question on my screen and then you can respond with your clicker. I don't think it's a system problem. It's your problem, I guess. So you can, close the app and open the app. And hopefully that's going to solve problem. Usually it does. Okay. So this is a bit challenging question. Let's see how did we do here. So mostly D. And that is correct answer. Object does not move at first. Slope 0 means does not move. Slope negative means it moves backward. And again, there is flat means not moving. So that's why D is correct answer. Okay, good job. So I talked about, you can tell about the acceleration from position versus time graph. Here I'm just repeating the same thing here, right? So it says compute the velocities at 4 second and 6 second. And acceleration is the change in velocity over the time interval. So at 4 second means here I have drawn the tangent line, and this is basically cropping from my note. I think it's on the note. So for that, I need to find the rise and run. So average means this over this means rise and run. Either one of those means exactly that. Okay. So you need to find slope of this tangent line. So I drew tangent line here. So how much is this rise? So this rise means delta V, sorry, delta X. Oh, for a moment, I guess we use that for the velocity versus time graph. Here, this is still position versus time graph. So that means it's going to be just initial velocity. Okay. Delta X over delta T. So rise over run. So how much is rise? It goes from 2 to 12, means it's a 10. And unit is meters. And how much is run? Can you type the run in this case? How much is run? Can you type that on the chat? Hey, it goes from 2 to 7 means 5. Yes. Oh, that's nice. So positive 2 meter over second. So that's the initial velocity. So to find at 6 seconds, we do the same thing. Okay, here it is tangent at that point. So let's try to figure out the slope. Okay, so which points are easier to read based on the line I have drawn? Looks like this is going to be run and this is going to be rise. Okay, so I don't see any convenient point to read over there, so I'm not going there. So this is going to be rise and this is going to be run. So that means BF. See here, this is TI 4 second means BI at that time means that is BI. So BF is again rise over run. And how much is rise? 14 minus 8 is that 6? And the unit is meters. And run goes from 5 to 6. So that means it is just 1 second. So that is 6 meter per second. So initial velocity was 2 meter per second, right? And it is now 6. So velocity increased from 2 meter per second to 6 meter per second. Velocity is increasing. So when something is sloping, when graph is sloping upward, something like this, that means velocity is increasing. Okay, it is accelerating and velocity is increasing. So what is average velocity? Average is this velocity change over time interval. So what is velocity change here? 6 meter per second minus 2 meter per second. Was that 2 meters? And what's the time interval here? We went from 4 seconds to 6 seconds, means it's a 2 seconds time interval. 4 to 6 means time difference is 2 seconds. 4 to 6 is 2, yes. So that 6 minus 2 is 4 divided by 2 is 2 meter per second over second. And we write that as a 2 meter second square. And this is actually positive. So acceleration, average acceleration is positive. So velocity is positive, acceleration is positive. Velocity and acceleration, they have same sign, means object is speeding up. Velocity is increasing. That's what we see here. Okay. So now here is another question for you. And you have a minute to answer this question. So there are two objects. One is moving something like this. Train A is moving, and train B has a curve. Train A has a straight line graph. Both of them are position versus time graphs. Thirty more seconds. Oh, 5 more seconds. 5, 4, 3, 2, 1, and it stops. Let's see what we got. So mostly A. Okay, let's think about A. Which statement is true? At time t is equal to tc, both trains have same velocity. I can see they have same position. So from position versus time graph, how do we figure out velocity? What do we look for to find velocity from position versus time graph? What did we learn? Do you remember? Yeah, I see one response on the chat. So change in position over time or displacement over time. So that's we calculate, we use that to calculate. If we are looking at the graph, we can think in terms of slope. So change in position over time is also slope. So we need to think in terms of slope. So do you think the slope of this line, blue line, and this dark line, they have same slope at that point? They don't have same slope. Means they don't have same velocity or speed. Okay, so that's why this is not correct. So to draw slope for, let's say, this curved line, you would draw something like that. That's going to be slope there. For A has just a straight line, means it has one slope no matter where you draw a tangent line. Okay. Both trains speed up all the time. See, train A has a constant speed. One slope. Here, what's happening? Slope. Is slope increasing or decreasing for line B? We had line something like this. slope increasing. Over here, we have lines something like this. So if I were to draw a tangent over here, that's going to look like that. And over here, that's going to look like that. So which slope is bigger? Later slope? Smaller slope? Bigger slope or larger slope? Slope is decreasing. Slope decreasing means velocity is decreasing. Okay. In this case, the object is slowing down. So B is not speeding up, it's slowing down, and A has a constant speed. So that's why this is not correct. Both trains have the same velocity at some time before TC. So TC is here, sometime here. Both of them have same velocity or speed. What that means? Does the slope of this B line matches with the slope of A line at any time? Can you see that? Somewhere between here and here, does the slope of this curve matches with slope of this? If you were to draw a tangent line somewhere here, does the slope of that gonna match with this? Slope matches means if two lines are parallel, slope is matching. If two lines are parallel, slope is matching. Okay, same slope. Two parallel lines, this line, that line, same slope, parallel lines. Same slope, parallel lines means same slope, okay? So now, this line, of course, is fixed. So for example, if I were to draw, so it looks like around here, it's kind of sloping just like that. So for example, if I draw a tangent line over here, this line and that line, they look parallel. So that means this is correct answer, okay? So C is correct answer in this case. Yeah, it is a bit difficult question. So don't forget velocity or speed. How do you find velocity or speed? From a position versus time graph, you look for slope. You find the slope, okay? Do not just read the graph. You read the graph to find position and displacement, but you find slope to find the velocity. Think in terms of slope to think about velocity or speed. And by the way, speed at a point is calculated same way the velocity is calculated. You draw a tangent line and you calculate that. So now, with all these, you should be able to complete the worksheet. So this is how the worksheet number 1 looks like. I have posted that on Canvas on the assignment section. I think it says WS1, okay? So there is a motion diagram and you are asked to draw the graph and draw some tangent lines, tangent line, and find the slopes. And what does that mean? We talked about all these, okay? If you feel like you need help, you can come back and look at our this class or look at the note. And just like we had these two lines, now we have two lines here, just like we had this in this question, just we did, okay? So it is very similar to what I just talked about. So with that, you should be able to answer that. And keep in mind the question has explain, 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 why, and so on. That is very important. That tells you, if you have understood. If you can explain, that means you have understood it. Okay. So don't miss that. So if your explanation is missing or wrong, I'll take a lot of points off while grading this. So this is due next week, uh, Tuesday night, I think night before the next class. I mean, the Wednesday class. So you have a week to complete this, but there are going to be new worksheet coming soon. Next class, there are going to be new worksheet. So you want to finish this during this weekend, if possible. Okay. And you can submit it. Okay, so we talked about position versus time graph. Now let's talk about velocity versus time graph. So we want to graph velocities. So we already saw motion diagram, and we already saw how to draw, let's say, these velocity lines in motion diagram. So what's happening here? Is velocity increasing, decreasing, or remaining same in this drawing? Increasing, decreasing, or constant? Can you type that on the chat? So yes, it is increasing. So let's say, I'm just writing a random number here. 2, 3, 4, 5, 6. Those are the values, meter per second. Okay. So they are increasing, let's say, something like that. So I can make a velocity versus time graph. What that means? Now this vertical axis has a velocity in it. Okay. Rather than position. Remember, we had x so far. So now we have velocity. Okay. And time. So now we can say, okay, this is 2. So it's like something like somewhere there. First point is somewhere there. Second point is second, somewhere there, and so on. So we can put those points. Okay. And draw a trend line. So now this is velocity versus time graph. So if you want to find velocity or speed, you just read the graph. What's the velocity at this time? Go and read, right? But if you want to find acceleration, remember acceleration is change in velocity over time interval. So that means you need to look at the slope because rise, run. So rise here means change in velocity, not change in position, not a displacement anymore. It is change in velocity. So slope gives you the acceleration. And now by rewriting this, see here for delta B, I wrote final minus initial. I'm just expanding, okay? And when I rearrange this equation, the acceleration is here. So I can bring this one to this side, means I can write like that. And if we start from 0 time, then I can just write t for time interval. So that's that. So this is one of the equation, first equation in kinematic equation sheet, okay? So it relates final velocity, initial velocity, acceleration, and time interval. So that's what it does, okay? So basically this comes from the definition of the acceleration. We are just writing this definition of acceleration in equation form, okay? So first kinematic equation is just definition of acceleration, rewritten in this format. How do I read this equation? Final velocity is equal to initial velocity plus acceleration times time interval. Okay, so that's how I read it. And direction of acceleration going to be same as the direction of change in velocity, not velocity, but change in velocity, because acceleration comes from change in velocity. Whatever direction change, the direction of change in velocity is, that's going to be direction of acceleration. Okay. So here I'm skipping this graph for a moment. For now, I'm going here to show you how to draw a change in velocity vector, okay? Uh, before we run out of time. So I'll bring that question that we saw at the beginning of next class, okay? But for now, let's look at this. So what's happening here? That's the motion diagram. So how do you find out direction of change in velocity? So this is a very important skill. So the PDF file that I have posted, frequently used skills, towards the top of that 2 pages file, there is this steps on how to draw change in velocity vector. It is very important, okay? So how do we draw? You take any two of them, okay? You take any two of them. One, you can call it initial. Next one, you can call it final. So to find change, change means final or later minus initial, okay? Not the other way around. So how do we draw it? So draw two consecutive arrows means either this and that, or this one and that one, or this one and that one, and so on. That's what it means, consecutive arrows, two arrows. So I'm grabbing B2 and B1. Ideally, I will draw right on top of it, but if I do that, both lines may not be visible, so that's why I draw a little bit on the side of the first one, okay? So see how I'm lining up tails together, okay? And then now you can think of this as an initial, you can think of this as a final when you have just two. Why final? Because this is second, this is first. So first is initial, second is final. Now we are just talking about two. We can call one initial, another one final, okay? So after you line up, what's the next step? In that next step, you are drawing the change in velocity vector, okay? So I'm just copying here. So now here is the important. So you draw delta B starting from tip of previous to later. Previous means BI to BF. Just like when you drew change in position, you went from initial to final, right? Initial to final. Same idea here. You go from tip of initial and this is tip of final. And that is change in velocity vector. So the direction of acceleration in this case, although object is moving this way, the acceleration is that way, and they are in opposite direction means it's slowing down. So that's why it is slowing down, okay? So that's how we use this. So you wanna, there are some practice slides here. You wanna practice them. I may also ask at least one question related to drawing something like this, okay, on the weekly. So there are going to be weekly assignment coming maybe by tomorrow or by Friday, okay? So, folks, I think it's time for me to let you go. So I'll be on the Zoom for 15 or 20 minutes. If you have a question, feel free to come there and ask. If you have quick question, you can stay behind here. I'll be here in few minutes here, right here. You will have chance to ask me question. but I won't be all the way to the 10:50 today. Uh, I have to go somewhere. So I'll be around up to 10:20 or something like that on the Zoom for the office hour. Okay, folks, for today. But tomorrow I'll be full time.